Well, how are you doing? Hopefully you can all hear me. I'll have to speak a bit quietly because it's late at night here and I have housemates asleep. So this is LIGO, okay? These are the LIGO arms in Hanford, okay, in the USA. Now, as you know, they must be straight. That's the whole point of them. And it's claimed, obviously, it's claimed by people who believe that we live on a globe, right? That these were built, right, totally straight, but the ground underneath them is curved, okay? So what I did here is I just brought a red line here across this photograph from one end to the other, right, to make a right angle triangle, okay? Pretty straightforward. Okay, so I'm going to go here first. Okay, LIGO, right? Each LIGO detector consists of two arms, each 4 kilometers, 2.5 miles long, right? So we know what length they are, approximately 2.5 miles in either direction, right? So let's go here. Okay, here's a path I laid out, right? Now it's pretty precise. It's not 100%, but it's good enough. So taking in the two arms here and the length between them, then it is 8.48 miles. It's probably slightly more, but just to give a rough estimate of what it is, 8.48 miles as a triangle, right? So if I go to the line, I will keep that there, and I just want to show some, right? So 1 second, right? So I'm just going to start here, right? Go in right close, and I'm going to take a distance between these two. Now remember, I'm using the Earth's surface here, right? So start here, and I come right out, and right out. This up, here, and over to here. So I zoom back in. I try and get it about the same, about there, right? Try and get it about the same at the corner. Some more about that. And click that. 3.52 miles, as you can see. So 3.52 miles. That's the length, right? Now that's along the surface of the Earth. 3.52 miles. That's the length that you're given. Okay. So if I just do it again, we start here, and we will do this a sec. And we just zoom back in. So I'm going from one station to the other, right? One LIGO station to the other, which means that I'm making a right angle triangle. Go about there, 3.52 miles. So between one station to the other is 3.52 miles. Let's say one end here of this arm to this end of this arm is 3.52 miles. So whether I used the surface of the Earth or I took a straight line from here to here is 3.52 miles, right? Now it might be slightly more, right, if I was more precise, right? But the point is that they're giving you the exact same reading, right? Now what we have here is a right angle triangle. Now this is the thing. They're claiming that, now I know, you all know this is a load of rubbish, but they're claiming that the surface of the Earth underneath the LIGO station here is curved, which means that this line here, right, has to be a curved distance, right? So I just showed the length, or just measured between the two corners of the two arms here, the end of the arms, along the surface of the Earth, and it was 3.52 miles. And now I've just done it here again, and I've used the ends of the two arms, and it's 3.52 miles. Now, that is a straight line distance, right? These arms here have to be straight because they're shooting lasers up and down them, right? That's the whole point, interferometry. So they must be straight, right? The two arms at the LIGO station. And this line is a straight line. Now, they're claiming that this line is curved, is a curved distance. Now, this is the subtlety. If this is straight and this is straight, but this is a curved distance, then that would mean that even though I've just showed this between the end of both arms is the same exact distance, length and distance, as it is if I use the surface of the Earth outside the ends of the two arms. So that would mean that this, if they're claiming this is a curved distance, and that these two arms are both 2.5 miles long or 4 kilometers each long, then that would mean that if this was a straight distance, then it has to be less than 3.52 miles. Because if this is a straight distance here, right? Now I know Google here show they're using Cartesian, right? So this is all flat. This is all measured flat. This is all shown to be flat, right? Because this is all tidal coordinates, which is Cartesian. So it's all flat out, using a flat plane, horizontal baseline. That's the way it's done, right? Cartesian. But the thing is that they are still claiming that the surface underneath the LIGO station is curved. So what would be the chord line distance then? Because if this line here is a curved distance, and it's not actually, like, even though it's a straight line, and it can't be anything else, because I just showed it to be a straight line, they have to claim it's a curved line. That would mean it's a curved distance. So that would mean that the chord line distance, right, would have to be less, right, than 3.52 miles. So if we use a triangle calculator, right, go in here, we go to right triangle calculator, right, A and B, right, A and B, 2.5 miles. That makes 3.5355. So that is a straight line distance. So what Google Earth is giving us, right, is like what is not a curved distance, because if it was a curved distance, then it would have to be greater than 3.5355 miles, because that would be a chord through a circle, because the chord line would have to be less in length than the curved distance over it. But this is actually giving us what it would actually be. And as I said, I probably wasn't as precise as I should have been, but it doesn't matter, because even though it's 3.52 miles, the actual distance is 3.5355. So it's actually more than what I showed, whereas it should be less. Because if this is 3.52 miles and this is a curved distance, and I just showed it's exactly the same if I just use the surface of the Earth, or if I used from one end to the other, it's still, because there's all this is all the Earth in between it, I showed that the both of them are 3.52 miles, right? Sorry, right. So, sorry. It's not what I want. Sorry. But it doesn't matter. This is just annoying me now. Sorry. So the point I'm making is this: that would have to be a different. How you could make that a different length? It's obviously a triangle, right? That would have to be a different length. This length here, because that would be a curved distance. So the chord line would have to be less than that. But I just showed what the chord would be. It would be 3.5355 miles. This means that there is no curvature underneath any of this. There can't be, because I just showed what has to be the chord length distance. And I just measured it both ways using Google of what it would be. And as I said, I wasn't even as precise as I should have been. But if I was precise, I would have got 3.5355. I got 3.52, right? So it's actually, what I came up with as a measurement along the surface of Earth was actually slightly less than what a chord line distance would be. So there's no way that the Earth can be a globe and LIGO exist. It's actually that simple, because the chord line would have to be less in length to make the right angle triangle between the two arms of LIGO. But it's not. As I said, I was actually slightly out. I wasn't as precise as I should have been, because it's actually 3.5355 as opposed to 3.52, which is what I measured. That's the end of that. LIGO proves that the Earth cannot be a globe. It's a flat plane. Thank you.